All right, hello everyone. Welcome to week 2 of applied math. Today, what we're going to be doing is what I'm going to call part 1 of basic math skills. So our text, the book that we have, you can even flip through, look at some of the chapters. We won't be covering every chapter in this class, but the our book by Paul Fischel, it goes through different topics where a minister would use math. And as I was going through it, I felt like there were a couple of math skills that he assumes everyone has going into it that I don't expect everyone to have. So in some of the emails I got from students and talking to different students, everyone's kind of at a different place, which is what I expected. So there's going to be different math skills I think that we're going to need before we start working on the budgeting or before we start working on the geometry a minister might want to use. So we're going to have the next 2 weeks. We're going to be looking at the math skills that are basically the prerequisites before we can get into the things that we believe a minister would use math for. A lot of this is really, I would say, is stuff you'd find in a pre-algebra class. So if you've taken math past the pre-algebra level and felt comfortable with it, you should have a pretty good time with these. So that's what these next 2 weeks will be. So let me share screen so you can see the PowerPoint. All right, here we go. All right, so like I said, we're on part 1 of basic math skills. And so the next couple weeks, we're going to go over some skills I think you need to have before performing certain operations that we're going to have in the text. So the skills that we'll cover will be order of operations, solving for x, and logic reasoning. That's the 3 skills we'll cover today. And then next week, we'll do rounding, calculating averages, and calculating fractions. Fractions, for a lot of people that aren't necessarily math people, fractions are like their worst fear. But we really need that for doing things like proportions, for doing measurements. Fractions, as annoying as they can be, are one of the more practical things in math. So we'll spend some time on that. So to begin, we're going to look at the order of operations. So the first thing we're going to look at is some important vocab. So that way, as we go through this class over the next couple months, when I use a certain word, you'll know what it means. Or if you're confused, you can go back to this lesson to remind yourself. So first off, something's going to come up as a variable. What a variable is, that's the word for a letter we have to represent a value that we don't know. So if we say 8 plus n equals 12, what we're saying is, let's try to figure out what's missing. What is it that we would need to add to 8 in order to get to 12? So instead of always just saying, what is it, or what's the missing value, you can just make up a number to replace, or I say add a number. You can make up a letter to replace that. Let's move this little thumbnail. So in those cases, n is the variable in each of those cases. Okay, a term. You'll hear me say as we go through different math operations, you'll hear me say combine like terms. So you'll hear me say eliminate the term. What a term is just numbers and variables. But the key for figuring out what's a term is that its terms are separated by plus and minus signs. So if you look, we have a plus 2. So a is one term, 2 is the other. If this said 3a plus 2, then 3a would be a term and 2 would be another term. So look right here. What are our terms right here? Well, 3m is a term, 6n is a term, and then minus 6 is a term. Okay. Notice too, when you're describing what a term is, you'll need to tell me if it's negative. You don't need to bother saying if it's positive. Okay, this might seem very basic, especially if I have people in this class that are really solid at math. You're like, well, duh. But the key is understanding what a term is so that when we say you need to move a term, you know what we're talking about. Coefficients. A coefficient is the number part of the term. So it'll typically be a number in front of a variable. So right here, if you have 3x plus 2y plus 7xy plus 5. I don't know why this became uneven, but we'll just roll with it. So the first term is 3, not 3x. Oh. Okay, hold on. So there's a mistake right here. So the first term is going to be 3x, but the coefficient of that first term is 3. So ignore what this is saying. This is a mistake. The first term is 3x, and that term's coefficient is 3. So this should be saying, let me actually, this right here, I'm just going to edit this right now. The first coefficient. Man, it's going to throw off my whole thing. All right, so just we'll leave it at term, but ignore the typo right there. I've actually used this for a algebra 2 class, so I don't know how I've missed this after I've used this slide for years. But anyways, so the first term is 3x and its coefficient is 3. Second term is 2y, the coefficient is 2. Third term is 7xy, the coefficient is 7. And then on this, the last term is 5, and it's just it's a 5. There's no variable in that one. Okay, so here's a couple of expressions. So in this expression, your coefficient is 6. All right, so just to be clear, the coefficient is its only coefficient. So that's why on this, we're not going to call 5 a coefficient because that's the whole term in and of itself. It doesn't have a number and a letter part. There's no variable. So it's only coefficient if it's in front of a variable. So right here, your coefficient is 6. 5, it is a term, but you don't have to bother differentiating between coefficient and variable because the whole term is 5. Okay, right here, what are our coefficients? So our first term is 8r. R is the variable, 8 is the coefficient. And then 7 is a coefficient, but not 4. 4 is alone. And then lastly, in this one, 14 is the coefficient. And then the last term we need to understand in this stuff is a constant. So a constant, what we see here, are numbers where the value will not change, or in other words, they're just solid numbers that don't have a variable. So if I was to say 6m plus 5, this front term of 6 times m, if m is 1, if m is 2, if m is 3, whatever m is, that will change this term. But this is a constant. No matter what we have for m, the 5 will always just be a 5. That's why we call it a constant. And so if I have 6m plus 5, the constant is 5. And the expression 8r plus 7m plus 4, the constant is 4. What are the coefficients there? 8 and 7. In the expression 14b minus 8, the constant is -8. Okay, so we have terms, and then within terms, we could have variables, which could have a coefficient in front. And then we could also have terms that are just constants. So that kind of covers everything. Why is this so important? Well, the reason it's so important is because maybe in like 6 weeks when we're doing something more difficult and the key to doing something is moving the term over, I want you to be able to focus on the more the skill we're focusing on at that point, rather than getting tripped up in like, well, hey, what's a term? So that's why in the early parts of this the math portion of what we're doing, it's important to make sure we know these terms. Okay, and then what's the difference between an expression and equation? Look at these right here. So if you look at these two, look at what you have here. Right here, 5 plus 2, and well, so is this. What makes it an equation, though, is the equal sign. So in an equation, you're always saying what your expression equals. So an expression doesn't have to have an equal sign. The equation does. Notice in this case, in each of these cases, it's the same thing. It's just turning into an equation by telling you what it equals. Okay. So 5x plus 3 right there. Is that an expression or an equation? Well, if you look, the expression doesn't have the equal sign. The equation does. So this would be an expression. And then let's look at what are the terms here. Well, 5x is one term and 3 is the other term. What are the coefficients here? 5 is one coefficient. What is the variable? X. What is the constant? 3. All right, so that's really everything to begin with. Make sure you understand these vocab terms. Is 5x squared plus x minus 7 an expression or an equation? In fact, here, let's do it like this. Let me put all the questions out here for you. Okay, so let's do one of these things. Pause right now. So I want you to pause the video. I want you to go through these. And so let me just say this. I probably should have said this at the opening. The way that now that we're doing actual math stuff where you're going to be solving problems, we'll treat this like an actual class as much as we can. So I don't want it to be something where you're literally just sitting there just watching me talk and do problems for an hour. That's a waste of your time. You're not going to absorb anything. Even though this recording, I don't expect my recordings to go much past an hour, but I expect them to take you 2 or 3 hours to get through the whole thing, because the way I'm going to structure these is that I'm going to go over something or demonstrate a skill, and then I'm going to want you to pause and try it yourself. So this is one of those moments. So what I want you to do is pause. I want you to go through these 5 questions. I would like you to actually have, I'm not going to make you ever send this to me or anything, but I'd like you to have a piece of paper out and work out the problems. So take out a piece of paper right now, no calculator, get something to write with, preferably a pencil. If you do a pen though, that's fine. And go through these 5 problems, try them out, make sure you know what's going on, write down your answers, and then after that you can press play and then watch me go through it and then double check how you did. All right, so we're at that point now. Press pause, answer these 5 questions, and then press play, and we'll go, and you'll see me go to the next slide, sometimes demonstrate it on the board and work out the problem. All right, so 5x squared plus x minus 7. This is an expression. You have no equal sign. How many terms are in 5x squared plus x minus 7? So your first term right here is there's 3 terms. The first term is 5x squared. The second term is x, and then the third term is 7. So your pluses and minuses separate your terms. So term 1, term 2, term 3. All right. So list the terms. What's your first term? 5x squared. What's your second term? X. What's your last term? Negative 7. What is the coefficient for 5x squared plus x minus 7? Now, I think a lot of people are just going to say 5. The only answer you'll put will be 5. And I understand why you would do that, because you say, well, there's no number in front of the x. But whenever you have a variable, you will always have a coefficient. And if nothing's there, then how many x's do you have? So first off, how many x squares do we have? We have 5 of those. So one of our coefficients is 5. How many plain x's do we have? We have 1 of them. And whenever you just have an x or you just have x, what you're assuming, what you're saying is I have 1x. You just don't need to say the 1 every time. So in this, your coefficients is 5 for the first term, and then the second term has a coefficient of 1, even though it's not written. And then what is the constant in 5x squared plus x minus 7? Well, right there, the constant is negative 7, because you have no variable there. All right. So that's it for these basic terms. All right. So now that we've done this, let's get into order of operations. I see these things pop up all the time. If you're ever on Facebook, you know what I'm talking about. People share these Facebook things. It will have some type of a expression like this, and then it's designed for everyone to argue over what the answer is. And it's always funny because it's like you'll see all these different numbers posted, and then the only thing that every person who participates in those has in common is that they all are positive that they're right, and then they argue on it. I think that's just the nature of discussions on Facebook, but that's not the topic I'm supposed to get into in this class. So anyways, today what we'll do is allow you to be the person that knows the right answer when those things pop up on your feed. So if you have 7 plus 4 times 3, is your answer going to be 33 or is your answer going to be 19? So think about what you could do. You could do 7 plus 4, which is 11, times 3, that's 33. And so if it was one of those Facebook things where it's a post of that, and then you'd have half the comments are people saying it's 33 and insulting everyone who says it's not 33. Or is it 19? Well, how would you get 19? You would get 19 by doing 4 times 3, that's 12. And now you have 12, you would add 7, and now you're at 19. Which one is it? And so the order of operations is designed to make sure that we do things in the right order, that we do the right thing first. And the types of problems that we'll have, the types of problems that we'll be doing when we apply them to a practical situation, you definitely need to have the order of operations down or it will become a mess. So you get two different answers depending on which one you did first. In order to make sure that we are all doing the same thing and doing it right, we use what is called, as I've said over and over, the order of operations. So I think you first the order of operations in like 4th or 5th grade math. So they have this little phrase, please excuse my dear Aunt Sally. That's the one that I was told in like 5th grade. And so please excuse my dear Aunt Sally. You can remember that. And then so what you come up with is PEMDAS. Both of these I have had drilled in my head for so long that I have both these memorized. Please excuse my dear Aunt Sally, and I have PEMDAS memorized. Either one works. But the reason why you memorize PEMDAS is because then you can write it down and have the order of operations, or in other words, what comes first to what comes last, like the order in which you need to do these math problems, you'll have it down if you just remember this phrase PEMDAS, or you remember, please excuse my dear Aunt Sally. So look how it goes. So PEMDAS. P is parentheses, or anything like a parentheses. So here you'll see I have a parenthesis, and here I have a bracket. So what that means is the very first thing you do in a math problem is whatever is inside the parentheses. All right, once you're done with that, the next thing you do, so please excuse, so the E is for exponent. And so after you've solved everything in the parentheses, before you do anything else, you need to go solve all of your exponents. So we have P, we have E, and then we have to get M, D, A, S. So the next thing you do is you multiply, and the next thing that you do is divide. This little thing right here is a key, is that multiplication and division, what you do is you'll do those from left to right. So whichever one comes first, as you read it from left to right, that's the thing that you have to do first. And then next, you will add and subtract, once again, from left to right. So please excuse my dear Aunt Sally, helps you to remember parentheses, exponents, multiply, divide, add, subtract. Do all those things in that order. When you do multiply and divide, which are on the same tier of importance, prioritize left to right. Add and subtract, same tier, prioritize left to right. Okay, so that's how we do the order of operations. So with that, 7 plus 4 times 3. What should we get? Should we get 33 or should we get 19? Well, we have addition. Where does addition come in? Addition is the very last step. We would do addition, subtraction last. So let's look what else we have here. 7 times plus 4 times 3. Well, 4 times 3, that's multiplication. That's higher up in the order. So you do that first. So 4 times 3 is 12. All right, so we have that. We multiplied first. And then plus 7, we should get to 19. So if we do, what about this? Let's evaluate this one. 14 divided by 7 times 2 minus 3. So in this one, I think what could happen is a lot of people would actually get this one correct by accident, because even if you're not sure the order of operations, a lot of people might just go from left to right, which in this case is good enough, because what would you do first? 14 divided by 7, and you would get 2. So see the way I've structured this? 14 divided by 7 is 2. All right. So this, the 14 divided by 7 becomes a 2. Now what are we going to do next? Well, we're going to do 2 times 2 to get 4. So now we're just stuck with 4 minus 3. 4 minus 3 gets us to 1. So in this, again, a lot of people will conveniently get this one right because they'll save subtraction for last. But if this subtraction part was put in the front, you would do that last. So this one, you should get 1. I don't really, the only way somebody would get this wrong is if for some reason they decided to subtract first and get a negative one right here, which would be weird because not only would they not know order of operations, they would also be for some reason working from right to left. So this would be 1. Okay, now we get to this. This one is a little bit more difficult because this one you wouldn't accidentally get it right if you didn't know the order of operations. So let's think, what's first? PEMDAS, P-E-M-D-A-S. So parentheses first. So you're not going to take this and do 7 squared and get a 49. Don't do that. Even though exponent is high up on the tier, parentheses comes first. So do 3 plus 7. See right here, 3 plus 7 gives you a 10. So now you have 3, and then 10 is in parentheses squared divided by 5. So what will we do next? So we've done P, we've done parentheses. Now we got to go to E, which is exponent. So solve what the exponent is, ignoring everything else that's around it. So what's 10 squared? Remember, exponent 10 squared is 10 times 10, which gets to 100. I'm not going to take a day to go over exponents. I'm expecting that we are comfortable with exponents. If you struggle with exponents, I would suggest that you shoot me an email. I might need to give you a little more like catch-up help to get us in. I guess, to be honest, though, exponents are not going to, well, yeah, there's some stuff when we're calculating. There's some stuff we'll do when we calculate things like with interest, some financial things where we'll need to use exponents. So you definitely need to be comfortable with exponents. It's not something I'm going to cover in these 2 weeks of prerequisites. So if exponent is something that you're not sure at all how to do that, please email me like ASAP and I'll get you a little extra help on that. But so 10 squared is going to be 100. And then we have 3 times 100 divided by 5. And well, which one do we do first? And since these are in, you remember with multiplication division, you just work from left to right. So 3 times 100 is 300. And then you divide by 5, and then you have 60. All right, next up, which of the following represents 11 squared plus 18 minus 3 squared times 5 in a simplified form? Let me say, as far as with calculators, I'm gonna be okay if you use calculators for something like this. Like, I don't necessarily expect you to do 11 squared in your head. You'll get to use calculators in real life. This is something though where I would rather you, how am I gonna put this? There's gonna be a day where we go over math tools, like the tools that you'll use that'll help you with math, because I want you to be able to actually do real life math problems. And in real life math problems, you can use Excel spreadsheets, you can use calculators. Like, we all have calculators on us at all times. So I'm okay if you use calculators. For this though, the way I'm gonna say I want you to try to do this is don't just plug this whole thing into the calculator and let the calculator give the answer, for a couple reasons. One of them is that you might plug this in wrong if you're not sure how to use order of operations. So what I'm saying is that you could use a calculator to solve 11 squared, and then say when you need to do, like, when you need to add 18, you could even do plus 18, but do one step at a time in the calculator is what I'm trying to say. So don't plug this whole thing in the calculator and let the calculator do order operations, because you don't get the practice, but also you might plug it in wrong because you're not picky about order operations. So with this, what I'm saying is you'll go like this. So 11 squared plus 18 minus 3 squared times 5. So let's figure out how we're going to do this. I think I need to stop sharing the screen so that you can see me okay. All right, so is this as blurry? Let me try to get this in focus a little bit better. Okay. So we have 11 squared. Hold on. I hope maybe the recording will be better, but right now the version of this that I'm looking at, it looks extremely blurry. Okay, that's a little better. Okay. So we have 11 squared plus 18 minus 3 squared times 5. So then what we're going to do, again, I'll even have a calculator out. I don't mind if you do 11 squared in the calculator, which will get you 121. So then we have 121 plus 18 minus, and you can just do all the exponents in one step. So the other thing we have is 3 squared, and 3 squared is 9. So minus 9 times 5. Okay, so now we have 121 plus 18 minus 9 times 5. So do I do the 121 plus 18 next? Do I do 18 minus 9? Do I do 9 times 5? We normally work left to right, but remember, in PEMDAS, multiplication is a higher priority than addition or subtraction. So do this part of it next. Okay, so we'll do 121 plus 18 minus, and you'll do 9 times 5, and you'll get 45. So again, I don't want you to plug this whole thing in the calculator, but if you use a calculator to do 11 squared and get 121, that's perfectly fine. If you need a calculator, do 9 times 5 to get 45. I'm fine with that. So now that we're just on addition and subtraction, we can work from left to right. So 121 plus 18 is going to get us 139, and then minus 45. Hold on one second. I think we have a, yeah, okay, so when we do 139 minus 45, I think that the multiple choice options in the PowerPoint are messed up then, because we don't even have the right answer. So I'll have to edit that. But so we'll do 139 minus 45, and we will get 96. Oh, I'm sorry. We'll get 94. So that would be the final answer. Okay. So Let me share screen again. And okay. So this should have had 94 as one of the options. So there we go. I'll fix that. So with this, these, when I did these, I came up with some of these by doing it the wrong way. And so just expect that when we get to when you take the quiz for this week, and then when you take the midterm, I think around week 5, week 6, expect it to work like this, where I'm going to give you some order operations questions, and I will do it the wrong way to calculate some of the wrong answers. So be ready for that. Okay, what about this one? So let's do this. I want to let you try this. So pause it, try this yourself, and then once you've done that, press play and check the right way to do it. Okay. So pause, try it yourself, press play, and then you can see me do it. All right. So by now you've tried it yourself. Hopefully I didn't make the same mistake I made on the last slide, and I've put the correct answer within those 4. All right. So let me write this. It's going to be 24 minus 6 times 4 divided by 2. Okay, so stop sharing. You can see what I'm doing. All right. So let's go through this in the right order. So 24 minus 6, we're going to do that last. That's subtraction. So now we're going to look on multiplication and division, working from left to right. So 6 times 4 is going to be 24. All right, now what's next on this level? Well, if you did 24 minus 24, you'd get 0 and divide by 2. You would do 0 divided by 2 and get 0. That's why I put 0 as one of the wrong answers on there. No, you don't do subtraction. Next up is division. So we'll have 24 minus, and then 24 divided by 2 is going to be 12. And then 24 minus 12 is going to be 12. So I don't imagine you're going to take a whole bunch of math classes if most of you reading through your emails. Seems like you're at a stage in life where this is probably the last math class that you'll take. So some maybe not, but so what I'm saying will really only apply in this class. But just once I get back to this, here we go. So watch out for stuff like this. See, I even showed you how I came up with the wrong answer of 0. So expect that in this math class and any others you ever take, for the multiple choice options to purposely put wrong answers in there that are there if you did the wrong calculation. So just because you did the calculation, you see the correct answer there, don't get all excited like, oh, they would only put the correct answer because I'm right. They'll put answers in there that are there if you took a wrong step. So watch out for that. All right. Next one, let's do this. Evaluate 20 minus 3 times 6 plus 10 squared plus 6 plus 1 times 4. Let's do it again. Pause it, work it out yourself, see what you get, press play, and see what I do. All right. Once again, I'm assuming you've done it by now, so let's see what we should get here. All right, so we should have 20 minus 3 times 6 plus 10 squared plus 6 plus 1 plus 4. Am I going off the screen with that? Looks like I'm just about to. Okay, so let's stop sharing. Okay. So what's first out of all this? Well, first would be parentheses. Okay. Notice what I'm doing. I'm rewriting everything. Don't get lazy with math where you just rush through things. I'm rewriting each step here. You'll see. Now let's do the next step. What's after parentheses? Well, next up would be exponents. Okay. Now what's next? Okay. Well, what's next is going to be the one multiplication we have on there. And now we just work from left to right. So 20 minus 18 is 2. This you probably could just do all at once, but I'm still going to be thorough. I'll do one step at a time. 102 plus 7 plus 4. 109 plus 4. 113. All right. Order of operations. Back to share screen. Okay. So that's order of operations. Okay. That's the first of our basic skills. And it's something that I think if you don't have that down, math is pretty much impossible. So if you're somebody who's always struggled with math, typically what happens for somebody who always had like a bad experience with math, it normally comes down to some earlier skill like that they never quite had down, and then it made all the stuff later on way harder than it had to be just because an early basic was missing. So that's our first skill. All right, next up is solving for x. So we're going to look at solving two-step equations. So if we have something like 3x minus 5, and if you can't off the top of your head just look at that and figure out what x is, right? Some of us will be able to look at that and figure out what x is without solving it, and that's always fine. All right. There's a problem where you don't need to go through the steps. That's actually fine. If you look at that and know what x is, great. You don't though, then we have some steps we'll go through. Same with this. If it's y over 4, y divided by 4 plus 3 equals 12. Again, if you can think in your head, what's the number that if I divide it by 4 and then add 3 to it, I'll get 12. If you can come up with that in your head, great. 5n plus 4 has to equal 6. So these are examples of two-step equations. So with two-step equations, what you're going to do is you're going to use what we're going to say call an inverse operation, or work backwards or undo whatever is happening to the variable, right? When I say variable, now I'm expecting you know what I mean after those first couple slides. The x, the b, the c, those are the variables. So in this case, you look at the variable, look at the term the variable's in, and you look at the coefficient that's in front of it, and what you're going to do is do an inverse operation or undo whatever that coefficient is doing. So if there's a 7 in front of the x, we need to get rid of 7. If there's a -5 in front of b, we're going to undo that. If there's a c divided by 2, we're going to be undoing that. So what we're going to do is we're going to work backwards to undo what's happening to the variable. And so because we're undoing it, we go backwards from the order of operations. So I guess what I could say is it's like if you're putting on clothes, you would put on the shirt and then the jacket. So then if you're taking off your clothes, what would you do? You wouldn't take the shirt off first. You go backwards from what you did. You would take the jacket off and then the shirt. So with this, it's like imagine that we put some clothes on our variable right there. And so the idea would be that what we did first, so I guess the way I'll put it is that we go, you put it on in a certain order and we'll go take it off in a different order. So in PEMDAS, what's last? Addition and subtraction. So that means we need to start with that. In the same way, when you're putting on your clothes, what did you put on last? The jacket. So when you're taking your clothes off, that's what you need to start with. So what it would be like is, since in the order of operations, we would multiply and then we would add. So when we're undoing the order of operations, you'll add and then multiply. That's something that makes up a lot of people. I mean, I teach sophomore math, I teach geometry. And so I teach people who supposedly have been in math and learning this stuff forever, and they still don't have this down. And it's really hard for a lot of students to solve equations simply because that's the step that confuses them, that whatever the order of operations is to basically layer and set up an equation, to undo the equation, you go backwards. So in this case, what we need to do is we need to start off, we want to get the x by itself. Well, multiplication would be before addition in normal order of operations. So since we're working backwards to undo the equation to get x alone, you will start with addition. So what we need to do is undo this part of the addition. Once we've undone that, we'll undo this multiplication. So what it will look like is If there's an addition problem, you will subtract to undo it. If there's a multiplication problem, you'll divide to undo it. Or backwards. Subtraction, we undo it with addition. Division, we undo with multiplication. So the way it works, the rule is when you do something on one side of the equation, you have to do exactly the same thing on the other side of the equal sign. So if we have x plus 1 equals 9, I think this might be a little confusing seeing it that way because it's everything at once. Let me stop for a second. So look, if you have x plus 1 equals 9, and the goal is to x alone. I'm starting with just making it simple. There's no coefficient. What will undo addition? So what undoes adding 1? Well, subtracting by that same amount. So you'll subtract by 1. The way to make this organized, to make it make the most sense, is to line everything up. So I'm gonna, and remember the equal sign is basically what separates things. So whatever you do on one side of the equal, you have to do on the other side of the equal. So if I did a -1 right here, I also have to do it right here. What happens when we do 1 minus 1? Well, it eliminates itself. That's the whole reason we subtracted by 1. So what do we have left here? We have x. We have an equal sign, and then what's 9 minus 1? 8. So x will equal 8. So back to the screen sharing. All right. So this is an example right here. X plus 1 equals 9. You do -1, and you end up with x equals 8. All right, moving on. When you do something on one side of the equation, you do exactly the same thing on the other side. So if it's x minus 1 equals 7, what undoes -1? Adding 1. So we'll do +1 on the left to eliminate -1 and +1. All that's left is x. +1 on the right. 7 plus 1 becomes 8. Okay. So now what about when we are left in the case where we do have something in front of the variable? What about something like this, where it's 2x plus 12 equals -10? I'm sorry, there we go. I was thinking I lost my eraser. It's sitting on my lap right here. All right. So what are we going to undo first? The multiplication or the addition? Remember, order of operations would say addition comes last. So when we're undoing the equation, addition is what we'll start with. So what we're going to do is we're going to undo the addition part, or in other cases, the subtraction. Undo addition and subtraction first, then you'll undo multiplication or division. So we got to inverse this. So same thing as last time. So it's 2x plus 12 equals -10. What do we do about this? Well, we will subtract it. After we undo the 12 by subtracting it, we're going to undo 2x. What does 2x mean? It means 2 multiplied by x. So multiplication is undone by doing division. So we're multiplying by 2. Well, then we'll have to divide by 2 to undo it. So the whole goal of this is to get the variable by itself by using the inverse or the opposite operations. So the goal, get the variable by itself, and you always do it by doing the same thing on both sides. And to undo it, you do the opposite operation of both sides. And in order to decide that, you go the opposite of the order of operations. So you do addition and subtraction first, and then you undo any multiplication or division. So let's look at a couple examples. So what are we going to do here? Should I deal with the 4 first or the 2 first? Deal with the 4. And how do you deal with the 4? It's +4, so you'll subtract 4 from both sides. Now, do it like the way it's written here, or the way it's typed in, is keep it orderly, keep everything lined up. That'll help you a lot whenever you're doing this. And so you have -4, in which they cancel out. So we have a 2x here, and then 10 minus 4, solve that, you have a 6. So now you have 2x equals 6. Now let's undo the multiplication. And the way we're going to undo multiplication is dividing both sides by 2. So 2 divided by 2 is 1, which remember from earlier, you don't need to write the coefficient 1. So we have x by itself, which was the whole goal. And then 6 divided by 2 is going to be 3. So we have x equals 3. And that's our final answer. A little trick is to check your work to make sure that you did it right. Go back to the original equation, the 2x plus 4 equals 10. You decided that x equals 3. So plug 3 in place of the x and see if it works out. So let's see. 2 times 3 is 6, plus 4 is 10, which 10 equals 10. We're good. So that's how you can always double check at the end to make sure you did it right. What about right here? What are we going to do about this? 3m minus 10 equals 17. So add 10 to both sides. So we do that and we'll get 3m equals 27, right? Negative 10 and 10 cancel out. 17 plus 10 is 27. Now what do? Divide both sides by 3. So this will be left with an m on the left. 27 divided by 3. That's going to become 9, and m equals 9. And then we can check the work. Go back to the original thing. Take that 9, plug it in place of m. So you'll do 3 times 9 minus 10. And when you do that, you'll get 27 minus 10, 17 equals 17. So you can, these are the type of math problems where you should never get them wrong, even if the multiple choice is trying to trick you, like I was showing you earlier, because once you get your answer, plug it back in to make sure it works. Okay, this is a little bit messed up the way it lined up. Again, it's just the way the PowerPoint stretches the screen. This is meant to be x over 3. So it's x over 3 minus 4 equals 8. So get rid of the negative 4 by doing plus 4. So it's gone. And then 8 plus 4. So we'll get x over 3 equals 12. And then how do you get rid of an x over 3? Let me see if I can. So again, I'm sorry this is not lined up right, but picture this little line just down slightly. So it should be saying x over 3 equals 12. So x over 3 is saying x divided by 3. And to undo division, you'll use multiplication. So you'll see the way it is on here. You do times 3 on the left, and times 3 and dividing by 3 are opposite functions. They'll cancel each other out. So x will be alone. But if you multiply the left by 3, you multiply the right by 3. And so all that's left over here on the left will be an x. And then that'll equal, you get 3 times 12, and so that'll equal 36. So x comes out to 36. Check your work, take the 36, plug it back in, 36 over 3. That will give you 12, and then 12 minus 4 gives you 8. So it all works out, and we did it right. Okay, what do we do here? This should start to get kind of easy, I'm hoping. Subtract 6 from both sides. So now we have x over 2 equals 8. Now what? Multiply both sides by 2. So now we have x equals 16. Plug 16 back in. 16 over 2 is 8, plus 6, 14. Okay, so another way to look at this. Think it in order of what should we do first. First, we will subtract 8. What do you do after that? You will divide by 3. What will we do first for this one? Add 10. What will we do after we add 10? Divide by 5. All right, are you seeing this? You just look at what this was doing and do the opposite of that. Look at what this was doing and do the opposite of that. X over 2 minus 4 equals 20. What are we going to do first? Undo the minus 4 by adding 4 to both sides. Then we need to undo x over 2 by multiplying by 2 on both sides. Negative 30 equals negative 5x plus 5. So what do we do first? First, we subtract the 5. Then you got to deal with this negative 5x. So we will divide by negative 5. All right, so some examples of solving these, just put written out for us. So we have 2x minus 5 equals 19. What's the opposite of subtracting by 5? Adding by 5. So then we'll have the 2x remains. Negative 5 and positive 5 undid each other. And then we have 19 plus 5 to get 24. So 2x equals 24. Now we will divide by 2. 2 divided by 2, we just have x left. 24 divided by 2, we'll have 12. Look over here. 15 plus x over 3 equals 6. So the first step is subtract by 15, subtract by 15. Now what we'll have is we'll have 6 minus 15, which equals -9. Right here, this overlapped a little bit. Again, one of these alignment problems with the screen. So imagine this 3 in parentheses is just slid to the right. So it's like over here. So what you'd have is you'd have x over 3, which is left from right here, equals -9. And where these red 3s come from is you have x over 3 and you need to get rid of this dividing by 3. Remember, x over 3 just means x is being divided by 3. And so what you'll do is you'll multiply by 3, because 3 and multiplying by 3, dividing by 3 cancel each other out. So the next line is x. But if you multiply the left by 3, you need to multiply the right by 3. So you'll have -9 times 3, and that becomes -27. So x comes out to -27 here. Okay, at 8x plus 1 equals 25. Subtract 1 from both sides, you have 8x equals 24. Divide by 8 on both sides, you'll have x equals 3. Okay, over here, x over 5 minus 4 equals 3. Subtract 4 from, or you have subtracting 4, so add 4 to both sides. So you'll get 7. Again, right here, the alignment is a little off, but you'll have the x over 5 equals 7. And then to undo this 5 on the bottom, you'll multiply by 5, and you'll get x equals 35. So you need to get rid of the addition of subtraction first, and then you need to get rid of the multiplication or the division. So I want to let you try these examples. So this is one of those moments. Let's pause it, try these 4 problems yourself. And then once you've tried them yourself, then you can press play and make sure that you've done them right. All right, so what we should get here is, in fact, I'm going to go ahead and I'll demonstrate them up here. So what you should get is x equals 11, y equals 6, n equals 8, b equals 2. If you did all of these right, I honestly don't mind if you, I don't know, fast forward like 2 or 3 minutes. If you don't need to see me do these examples because you did them right, that's fine. But I'm going to stop sharing. I'm going to go ahead and go through these problems real quick for anybody who needs to see how to do them. If you tried them yourself, you got stuck, or if you tried them, did them wrong, let's see what needed to happen here. So 2x minus 5 equals 17. And so for this, we need to go plus 5 on both sides. And so we'll have 2x equals 17 plus 5 is 22. Divide by 2. X equals 11. Okay. Next one was 3y plus 7 equals 25. And then so we're going to subtract 7 from both sides. So 25 minus 7, we're going to have 18. Divide both sides by 3. Y comes out to 6. Okay, next one we have 5n minus 2 equals 38. And we're going to add 2 to both sides. And so 5n equals 40. And then we're going to divide both sides by 5. And so n equals 8. All right, and then last one, 12b plus 4 equals 28. And so we're going to subtract 4. And we'll have 12b equals 24. And then we will divide by 12. And we get b equals 24 divided by 12 is 2. So that's how we get all of those answers, okay? So you just the more you do this, the easier it gets, the faster it gets. It just kind of gets to where you don't have to think too hard about it as you keep practicing it. Okay, so let's go back to sharing the screen. And okay. All right, let's try these ones now, where you're going to have some division going on. Hold on a second. This is definitely a typo right here. There's not supposed to be a 5 here. All right. So let's try these examples where you have to deal with undoing division. So again, press pause, go ahead, work these out yourself, and then press play to see the answers. All right, so I'll do it the same thing as last time. I'll go through, show you the answers you're gonna get, and make sure you did them right. And then I'm gonna show you how to do each of these. So if you did something wrong, you can see where your mistake was. So we have x over 5 minus 3 equals 8. So we're going to add 3 to both sides. X over 5 equals 11. And then now how do you undo dividing by 5? Multiply by 5. And whatever you do on the left, you do it on the right. So 5 cancels out. We have x equals 55. Okay, next problem is c over 7 plus 4 equals 9. Okay, so we're going to subtract 4 from both sides. So we'll have c over 7 equals, and 9 minus 4 is 5. And now we need to get rid of that 7. So if it's dividing by 7, multiply by 7. Cancels out on both sides. C equals 35. Okay, then the next thing we're going to have r over 3 minus 6 equals 2. Okay, so we're going to add 6 to both sides. And so we have r over 3 equals 8. And then we're going to multiply both sides by 3. And we have r equals 24. Last one. D over 9 plus 4 equals 5. Let's subtract 4 from both sides. And so we have D over 9 equals 5 minus 4 gives us 1. And then we have to multiply both sides by 9. So D is all that's left. And then 1 times 9 is just 9. All right, so that's how we get each of those answers. So that's solving for x. I think that's okay. So order of operations, solving for x. Again, I'm titling this basic math skills because these are things that I don't think are anything that's super advanced. But some of you took math a long time ago. Maybe some of you took math before you were saved and there was just zero discipline in your life. I mean, some of you maybe took math while you were saved and just didn't have any discipline in your life and didn't see any purpose to the math. So you didn't really pay attention. So these are skills that we're taking the time to go over these because you just need to have these in order to proceed with the things we'll do in this class. All right, so let's look at our last skill for this lesson. And this is just I'm tired. There's different names for this. You could call it critical thinking. I'm calling it basic logic and reasoning. And so we're going to take the most basic math functions and use them to learn how to order things the right way and explain things. And so when you're explaining math problems, one way to explain a math problem is to create something called a two-column proof. The way you're going to make a two-column proof, let me erase what I have here. So the way a two-column proof works is, as you could have guessed, you make two columns. And on the left, you'll have your statements. And then on the right, you'll have your reasons. Now, this is one of those instances where the stuff we do in math, I think, has so much application to like what I was talking about in the first lesson, where the things that you do in math, they just help your brain. They teach you to think in a way that is so applicable to things in life that have absolutely, seemingly nothing to do with math. And taking a basic math problem and organizing it into a two-column proof, where every step that you take in the problem, you explain why you can take that step. Getting your mind to think that way is really helpful. It's really helpful in arguing. It's helpful in apologetics. It's helpful in explaining yourself. It's helpful in breaking down things that you understand and trying to break them down so that others can understand it. It's helpful in figuring out what it is that somebody is saying that you don't get, so you can ask the right kind of questions in order to get the answers that you need. I think it's Proverbs. It's a verse that I always quote. I always say it, even though I think it's chapter 20, verse 5. But there's this, it's one of those Proverbs that I had read, and I was like, wow, that makes sense. And what it says, wisdom in the heart of a man is like deep water. And then it says, but a man of understanding draws it out. And so for me, it's always meant that it's like people will have this level of wisdom in them. And then on your end, it takes a level of understanding to know the kind of questions you need to ask in order to pull out of them the wisdom that you need to get. And so, as weird as this sounds, doing this kind of math really helps your mind to get to that point of being able to think to yourself, here's the 5 statements you've made, and I get all of those except for statement number 3. I don't get why that one works. What did that have to do with statement 1 and 2 that you made? Explain your reason a little more, right? So for you being able to think that way so that you can properly explain your reasons to other people when you're making statements, or you just have that conversational skill where when you're talking to somebody and you don't really get where they came from on one of the points they made, it's just helps to get your thinking ordered and helps to get your thinking logical. So we're going to do this with the most basic math with some of the solving for X we did, but we're going to learn to do it where anything that you say, you have a reason for it. And this approach is just helpful in any conversation you're going to have. So you're only going to make a statement to somebody if you can back that statement up with a reason. I mean, imagine how much easier all of our conversations would be. Imagine how much less people would have to post on Facebook and social media if you only ever said something if you had a reason to back up what you said. And the other thing you need to make sure you understand, and this is what I'm saying right now, takes this and it gives it more application outside of math, but you also have to use a reason that is either undeniably true, it's been proven somehow, or at least it's a reason the person agrees with you on. And if they don't agree with a reason that you're trying to use, you then need to backtrack a step and establish that as a reason that can be used. So, I mean, for example, if I'm trying to talk to somebody and it's just some random person on the street, and I'm trying to explain to them why they should believe in Jesus. So if I haven't established where they're at with the Bible, then there's definitely the principle that you could quote a Bible verse knowing that the power of God is going to use that. It's going to force them to retain it. and that Bible verse, the word doesn't return void. So there's something to be said for using the Bible verses and just quoting Bible to people and quoting scripture. For all sorts of stories of scripture haunting people and they just can't get out their head. So there's something to be said for that for sure. But if you're trying to explain something to somebody and you haven't decided whether or not they believe in the Bible, then if you say something and then your reasoning is that you quote the Bible, if they don't believe in the Bible, they might not buy that reason. So the point is that you got to use a reason that the person will accept. Otherwise, it doesn't explain your statement. So let's get into the math version of this. And as we do it, I'll try to flesh out some of the way this logic applies to other things. But let's look at math. So the critical thinking skills that math provides, putting problems into proofs, it's a really good way to work on logic and reasoning that's used in apologetics, as I was just saying. When you make a statement, you justify it with a reason that has already been proven or argued for. So I guess my point I was just making a second ago is that if I'm going to take a person and they don't believe the Bible at all, and they don't think the Bible is worth listening to, and then I'm going to tell them that they should believe in Jesus. And then if they say why, and my reason is because the Bible says to, like, that doesn't go anywhere. So if I'm going to say you need to believe in Jesus, and my reason, so like statements, reasons, if my statement's going to be you should believe in Jesus, and they say why, and my reason is because the Bible says so. Well, if they already told me they want to do whatever the Bible says, okay, good. That's a good enough reason. But if they haven't said that, what do I need to do then? Right? So if it's a person who hasn't told me that they're going to do what the Bible says, and I told them believe in Jesus, they ask me why. I either need to give them a different reason, a different explanation, or maybe my statement of believe in Jesus shouldn't be my first statement. It should be my second statement. And my first statement should be, you should do what the Bible says. And if they ask me why, I can then give them good reasons to do what the Bible says. Now, if they're on with me on if that reason has explained it to them and they're on board with the statement, do what the Bible says, now, since that's an established, agreed upon, theorem, to use a math term, since they're on board with that, now that can be used as a reason on something else. So now I can say believe in Jesus. Why? Because that's what the Bible says. I'm trying to use the most basic example, but the point is that when you give somebody a statement, you need to use a reason, have a reason to back that up. And a lot of our conversations go awry, or a lot of our apologetics will miss steps because we'll be trying to use reasons that we haven't argued for yet, or we haven't gotten them on board with yet. And so you either need to change your reason or take a few steps back and get them to believe in that reason so you can use it later. That's the type of thinking I'm trying to break down for you. And a really good way to develop that way of thinking and just practice it and just discipline your mind into approaching things that way is this type of math we're going to look at. So we're going to use very basic algebraic properties. So look at this slide, and here's some algebra properties that are just true, that are just proven, they're argued for, they're established. So you can, so look at what this is doing. If A equals B, then A plus C equals B plus C. Look at what it's saying. It's saying if things are equal, well, then they're still equal if I add something to both of them. So like if A is B, you could fill anything in for C. If these two things are equal and you add 5 to both of them, they're still equal, right? If I'm as old as you, will we both be the same age in 5 years? Yeah. If I'm as tall as you, will we both be the same height if you added a foot to our height? Yeah. If I weigh the same as you and we both lose 20 pounds, would we be the same weight? Yeah. That's the point of the addition and the subtraction property. If two things are equal, they're still equal if you add the same amount, or they're still equal if they lose the same amount. It's a property that does make sense. But the point is that if you were going to use that statement in a discussion, so if you do something and the person says why, the point of this is that instead of having to break this down, you can just say the addition property is the reason why what I just did was allowed. So the way this is going to work is if I'm going to take a problem, let's do this. If I'm going to do this, x plus 2 equals 7, and my next statement is x equals 5. Can you see what I did there? This is part of why we did solving for x before we get into these properties. What did I do there? Can y'all can you see what I did? I got rid of 2 from there, didn't I? And I got rid of 2 from there, didn't I? And what do I have here? I have x equals 5. So I took 2 off of both sides. If somebody said, okay, I get why that's there, but why does that happen? What I could do is this. I would say my reason for going from here to here, the reason that works is because of the subtraction property. What does the subtraction property say? It says that you can take something off of both sides of an equation and it still works. And so I don't have to go through explaining everything that I did. I just bring up the subtraction property because that is something that already argues for the fact that what I'm doing is true. So this is also a really good way to have a discussion with somebody is if there's like already an established principle or somewhere else the argument has already been set up or there's a simplified version of a long explanation you could give. If you make a statement and they go, well, why is that true? You can bring up something else that will argue that for you. And that can be helpful sometimes. And so say there's some, I don't know, some long sermon that establishes something. And that's why I believe that thing now. Or there's some book I read. Or maybe it's even I got it out of a chapter of the Bible. If that's my reason for believing in something, it's good to understand this that if I make a statement and they go, why is that statement true? And the property that I'm using is some type of biblical thing that I got out of a book or a chapter of the Bible, something, a sermon I read, some conversation I had, I can bring that up. And it basically means that the person won't really get where I'm going until they go look at that themselves. And sometimes that can be helpful in a conversation for you to realize your reason for believing something is something this other person hasn't looked into yet. And they need to look into it before they'll be on board with what you're doing. And so in math, I could be like, look, this leads to that. And if somebody goes, why? I don't understand that. I could say, go look into the subtraction property. If you understand the subtraction property, you'll understand what's happening here. And um, so subtraction and addition property. In a similar vein, you'll have the multiplication and division. Look at multiplication. If A equals B, and then if I just multiply both sides by C, they'll still be equal, right? If you and I are the same age and both of us double our age, we'll still be the same age. Division property, if A equals B, one thing in this is that as long as C is not 0, because if you put 0 on the bottom of something, it becomes undefined. It's just, it'll break your calculator. So if A equals B, well, then dividing A and dividing B by C, they'll still be the same. So that's another property we could argue for. The symmetric property, this kind of seems obvious, but especially like in a geometry or trigonometry class, if you're arguing for a problem, sometimes the symmetric property is going to be helpful. And it's that if A equals B, well, then the opposite order, B would equal A. And then the transitive property, this one is that if A equals B and if B equals C, well, then A just equals C. So a way I could break this one down is think about it. It would be like, if I'm the same age as Bill, and if Bill is the same age as Bob, what do you know about me and Bob? Right? You follow my logic here? If I'm the same age as Bob, and then is that the way I said it the first time? I think I said Bill. Okay, so if I'm the same age as Bill, and then Bill is the same age as Bob, what do you know about me and Bob? We're the same age, right? So if I'm 33 and Bill is 33 and Bob is 33, because I'm the same as Bill, Bill is the same as Bob, you could just remove that and go, well, A must be equal to C. That's what transitive is doing. If A is equal to B, and if B is equal to C, well, then A just must be equal to C. This is a helpful property for if there's a problem where there's something that's happening and it's confused a person, this property can give you a very simple explanation for them. So let me put an example up here of this. This would look like this. If we're doing some type of a math problem, and somewhere in here we established that maybe over here we established x equals 2, and then we do a bunch of other statements, and then somewhere down the line we establish that y equals 2. We have some other statements. Well, then since we already established that x equals 2, and we got the person on board for that, and then we got y equals 2, and we got the person on board for that, this stuff's been established and argued for. I can do this. X would equal y. How come x equals y? Well, they're both 2. So if these are both 2, then they're both the same thing. Instead of explaining that and with some type of a long explanation of like, if they're both 2, they both have to be the same. Well, that's the transitive property, right? Transitive is that if A equals B and B equals C, then A equals C. But you could put anything in place for A, B, and C. So instead of A, we're saying X. Instead of B, we're saying 2. So if X is 2 and if 2 is Y, then X is just equal to Y. And so right here, you could just say transitive property. So, I mean, this is stuff that like thinking this way, being able to connect information, again, it helps. It helps in it's going to be extremely important in math, and it helps in discussions. Like I said in the opening video, I'm part of a ministry where we'll go out to the streets and we're always getting in these apologetics discussions. And again, I don't want to overcomplicate it. If you just know a few Bible verses, know what Jesus did, that's all you need to go preach the gospel. There are cases, though, where it is helpful to be able to think this way. If there's a discussion where somebody has certain questions, it just kind of helps you to, I guess, cut to the chase and get to the point and figure out what kind of questions they need answered. So, so I think I have one more property for you here. I think the last property is the substitution property, which is just if A equals B, then A can be substituted for B at any point in the equation. Okay. Oh, of course, distributive property. If A is up against a parenthesis of B times B plus C. I'm sorry, let me say that again. Give me 1 second. So it's if A is up against the parentheses B plus C, what you can do is distribute A into both of those and make it A times B plus A times C. So if you have something in the parenthesis, you're allowed to take that and multiply it by both terms inside the parenthesis. It kind of looks like a violation of order operations, but it's not. It works that way. All right. So look at this. Look at this problem right here. 5x minus 18 equals 3x plus 2. So again, we're solving these solving for x here. But what you'll see is you explain each step and how you got there. So the first line, what we'll do is we'll just say given, meaning given equation. So look at this line and try to tell me, how did they get there? How did they do anything about negative 18? No, they did not. Did they do anything about the 2? No. Look what they did. 3x is suddenly gone. 5x is suddenly turned to 2x. Can you see what happened on both sides? They subtracted 3x from both sides. And look at what property leads from here to here. The subtraction property. Okay, so you basically don't have to show all your work when you're doing a proof like this, and it's a better way of explaining yourself because you're telling them what property they would need to make sure they understand for them to get why this could lead to that. Okay, look right now, 2x minus 18 equals 2, and suddenly it's 2x equals 20. What happened to both sides? Well, the negative 18 is suddenly gone, right? It's 2x minus 18, and suddenly it's 2x. So they did plus 18 to eliminate it from the left. So on the right, what they do? Plus 18. And what's 2 plus 18? 20. So how does this get to there? With the addition property. And then lastly, 2x equals 20, and suddenly x equals 10. What did they do? They divided both sides by 2. So how did this get there? With the division property. So instead of showing all the steps, you're explaining the basic property that let you do the steps that you did. And that's a better way of explaining something to somebody, is you quote the property or you quote the undeniable thing that they would need to go look up in order to understand what it is you're talking about. And if it's in a conversation where you want them to agree with you and understand where you're at, you could bring up the subtraction property. If they look at you weird, you then explain what the subtraction property is. They get that, you've now won them over. So it could be let's go. I'll go with sports. I don't know if I have students in here that follow sports, that like sports, but um, somebody could make a statement and well, you know what? I'm sorry. Completely ignore that. I'm not going to go with the sports example. I want to stick to the math so we can get through this. Maybe at the end I'll give you random examples, but I don't think we need more examples to make this relatable. Let's just look at the math. So what you do when you make a two-column proof, you're going to take steps, and you have reasons on the left, statements on the right. And the first reason is normally just going to be given. You're going to say given for your first reason. So look at this. This is the same thing we did here, but we put it into the nice two-column proof. So your statement is that 5x minus 18 equals 3x plus 2. Well, why is that true? That's what we were given. That's what we started with. And then we subtracted from both sides. And you don't have to show the subtraction that you did. Sometimes when I teach this at high school, I will, in a different color ink, draw what I did to both sides so you can see it. But typically when you're making a proof like this, you don't need to show what you did. You just show what answer you get after you applied this property. So I did the subtraction property. In this case, subtracted 3x from both sides. So it's eliminated here. 5x minus 3x, we get 2x. Then we added to both sides. Then we divide on both sides. So I think we're about done here. So let's I'm not going to go through a ton of examples on this because it's basically solving for x like we were doing. But look at how this works. Given that 55z minus 3 times 9z plus 12 equals negative 64, prove that z equals negative 1. So you know that z is going to equal negative 1. So let me start the proof off. So it's given 55z. You know what? I'm going to need to give myself some more room on this proof. So given 55z minus 3 times 9z plus 12 equals negative 64. So that's a long statement. And then I'm going to give my reasons. Let's use this to prove that z equals negative 1. So I'm going to stop sharing this. So I'm going to have you do these one at a time. I want to let you try it. Do the best you can. Get as far as you can. Try to solve the problem from here to here. But what's different between this and just solving for x like before is that you're going to do it step by step, explaining each step. So your first reason is always given. Okay, this was the given equation. Now, as you do each step, this is going to be a little weird. You're not going to write out what you did. If you want to, you can, but do it kind of small. And then you're going to show me what you get as an answer and explain what property lets you get there. If you, so let me do this. Let me go back. Let's do this. Let me make things a little easier for you. So here are our properties. If you want to like take a picture with your phone, print this off, or just mark where this is at in the video to go back to this, here's your properties you can use. Okay. So I'll wait a second. Make sure you have this. So you're going to use those, and I want you to try to do this problem first. So let's press pause. I want you to try to go through this and write out this proof step by step where you give me each reason. Go ahead and do it yourself. And then once you've tried it, you can press play and watch me do it to make sure that you're on the right track. Okay, if you're at this point in the video, I'm assuming you've done this proof, you've tried it yourself. Let's go through each step. So in this case, what will be the next step here? We'll do this. I'll show you what it looks like and see if you can, maybe you did the proof, no problem, and you're good. Some of these steps were hard. Watch what I do, and I'll give you a second to think about it. So I'm not going to touch that, but here is the first thing I'm going to do. So see, this becomes negative 27z. Okay, so look what I have. 55z minus 27z minus 36 equals 64. What did I do on this step? I distributed that to both of them, right? You see that? I took the negative 3 and I distributed it to the 9z and to the 12. And negative 3 times 9 got me negative 27. Negative 3 times 12 got me negative 36. So what property did I use? I used it's okay if you shorthanded a little bit. I'll just write PROP for prop. I used the distributive property. So that's what our first step would be. Okay. What do we need to do next? We need to add 36 to both sides. Okay. But I'm not going to, again, you don't need to write out what you did. So we'll have 55z minus 27z. And then what's going to happen is if you do plus 36, that's going to be gone. And if you do negative 64 plus 36, that will leave us with negative, I think that'll be 28. 8. It's made of 44. Yeah. Okay. So I'm going to write something here that I'll erase, but what this would have looked like if you were working out the problem, not explaining these steps, you'll go plus 36 plus 36. You see that? So it's plus 36 cancels out that negative 36. And then negative 64 plus 36 gets us to negative 28. Okay. This is a step that can be very, very strange. Oh, I didn't write my reason. What did I do on both sides? I used the addition property. Okay. So what you need to do now is we need to combine these like terms. We're going to do 55z minus 27z. And what we get here, because this is, we don't want to deal with this. So what we wanted to do is we want to do 55 minus 27, and that will get us 28z equals negative 28. Okay, so let me explain it this way. You could do this and it wouldn't be wrong. Okay, you could put something like this. Okay, you could say that you combined like terms, and I'd be fine with that. You could put that you took those, you combined them. However, when you're writing out a proof and if you're using properties, the property you say you'd use, anytime you take something and you just simplify it, that's an example of a substitution property. So substitution property is if it said 1 plus 1, and on the next line you put 2 in that place. If it said 4 over 2, and you put a 2 in its place. If it said 5x minus 2x, and you put 3x in its place. Anytime what you do is take a line to just simplify something and give it an easier answer or an easier version of the same thing, you're just substituting in an easier version of what you had above. So, and you can do that at any point in a problem. That's kind of what the substitution property establishes, is anything that's equal to something else, you can replace it with what it equals at any point that it's convenient in the problem. So again, substitution property is a weird property that comes up. Almost every step in math involves some type of a substitution. So that's why if you were remember the whole goal of this, and this is a kind of a weird part of math for a lot of people because there's not always necessarily just one right answer. Because what you're doing is you're giving me a reason, and you can shortcut the reason by naming the property. But that's why on something like this, if this was some type of a high pressure test, which let me just tell you now that any type of a test question you get involving this stuff will be more like there's an example and you say if the step was correct. I'm not going to make you write out a whole 2-column proof on your own for a test. It'll more be like it'll be one line will be blank and you say what property belongs in that line. So don't, if this is looking kind of weird for you, don't stress yourself out over this, because the problem I'll have you do for a test question will be a lot easier than doing a whole proof. I just want you to see and spend a little time working on this mathematical concept of every statement has a reason. So here we are with this. How do you end this? How do you go from, so let me line this up a little better. How do we go to what we needed to prove, which is that z equals -1? How do you get there? If you have 28z equals -28, and suddenly you have z equals -1. You're dividing both sides by 28. So you're using the division property, okay? So that is how we would do a proof like that. This is, I gave you a bit of a solving for x problem that's a little bit harder than our earlier solving for x, and I wanted you to do it with these order of each step. So this is where we're getting earlier on. We're definitely at a pre-algebra level. We're a step up from there right now. All right, let's do one more example. So let's go back. So I'll write this out. Trying to be careful here where I keep my columns up. So this one's going to be given that 25 equals 9x plus 5 all over 2. That's given. Let's prove that x equals 5. All right. I just noticed, I think the recording will say this. I just noticed that it says Jared Walker down here. You can ignore that. This is not Jared Walker right now. This is I think I can change that, but it's just, we're almost done. It's not worth it. I'm just using his Zoom, so don't think that your teacher got swapped out for somebody. But anyways, let's get to this last problem. So I want you to go through each step, try to solve this, and then it might make sense to even solve it on a different piece of paper. And then once you've gone through in your own head doing it however you need to, do it in the nice, neat 2-column form where you just give me each step and explain why that step works. So press pause, try this yourself, and then press play and watch me go through it. Okay, so what would be the first step here? Well, the first step would be to do this. Let me write what it looks like, and hopefully you can see what it is. Okay, that's the first step. What did I do to both sides? I multiplied both sides by 2. So I used the multiplication property on both sides. Okay, now what needs to happen next? Are we going to subtract the 5? Or are we going to divide by the 9? What are we going to do next? We're going to subtract 5 from both sides. So the next step would look like this. Okay, what did I do on both sides? Subtracted. This kind of lazy way of writing it, like, see, I didn't write out the whole word multiplication. I wrote enough so you know what I'm talking about. Whenever you're doing a proof, don't ever do that with subtraction or substitution because they both start with sub. So don't ever just write sub property because you know if it's a substitution or subtraction. Okay, so now we end up here. where we divide both sides by 9. We get 5 equals x. So what did we do here? We used division property. Okay, and now look, 5 equals x, x equals 5. Well, what's going on there? It is kind of obvious that if 5 equals x, x would equal 5. But remember this property right here, the symmetric property. If a equals b, then b equals a. So that last property is the symmetric property. So the last property is the symmetric property. So that's what we should get with that. All right, so let me just, I think this is probably the most difficult thing we've done, or at least out of everything we looked at so far, the thing where you could feel like you're unsure of how to do this. So I will just reassure you that the type of test question I'll give you for this. So actually, before I even say that, let me bring up one thing. The way I'm ending, and I'll make sure to do this at the end of every lesson. When we get to where we're following the math out of the book, there's going to be problems in the book. So towards the end of each lesson, when we're in the book, I'll have you work out the problems that are in the book. The next page will have the answers, but I will end the lesson by going through those. After you've tried them, I'll go through them. And then when it's all said and done, I'll have a page of just a few review questions. This is really just there. So if say you go through the whole hour or 2-hour lecture, you feel solid on it, you write some notes, but you're like, I don't know, you've had a busy week. Maybe you're taking multiple classes, looking at other lectures. You've got a life, you're doing a bunch of stuff. And maybe it's a few days later and you think, oh, I got to knock out that quiz. The review questions are here where you could pull it up and be like, let me just double check to make sure I feel solid about what we did. And you could run through the review questions. It just reminds you what was in there. You can do these. I'm not going to work these ones out. I'm just going to leave them here as just some questions that you could go pull up to make sure that you feel solid going into it. But with this review question, notice right here, I have one that's the above equation has a 2-column proof. That won't be the level of difficulty I would give you on a test. Let me share the screen, or let me show you one more thing. And then we'll call it a day. The way I would give you a test question would probably be just something like this. So instead of the whole 2-column proof, I'll do something like this. I'll do like a line out of a 2-column proof, and you tell me which property. So remember, it'll be multiple choice, and it will be like this. Be like 2x plus 5 equals 12. And then the next line will say, and I say, which property is a reason to justify that statement? And so the type of thing you'll see on the quiz for this, it'll just be, you'll say which property that is. In this case, that would be the subtraction property because you subtract 5 from both sides. Okay, so I just don't want you to be intimidated by the 2-column proof. I'm having you practice them. I would like you to be able to do a whole 2-column proof, but if you can't quite do it, as long as you just kind of can get how to do each line, then for one, you're getting the math skill that you need for the future. And then the bigger picture is just you learning how to organize that stuff logically is really the benefit I think you get out of it. But you working on the 2-column proofs and understanding at least some of what's going on there does enough of that. So don't be intimidated if you can't do a whole 2-column proof on your own. It comes up in a geometry class I teach, and I'll have students that pass the class, even ace the class. We do 2-column proofs all year long, and they struggle with it all year long. So I don't want you intimidated or feeling discouraged if this 2-column proof thing is difficult. This is the level I want you to be able to do. I want you to be able to look at that and tell me that that is subtraction. Okay, so that's it for this lesson. Make sure that you keep up with the discussion boards. Basically, there will be something to think about nearly every week with those because they'll be posted a week ahead of time, and you'll have a week to work on the opening response. It'll be due, and then you'll have the next week to work on responding to somebody else's post. So it's kind of a 2-week project, even though, so for example, this week, even though it's due in week 2, you needed to spend week 1 thinking about your opening answer. I set it to be due on Tuesday of week 2 for your opening response to my question I posted. Everyone will have posted a response by Tuesday, and then you'll have from Tuesday till the next Sunday to respond to what everyone else said. So let me just remind you, keep looking at the discussion boards. And of course, if you have questions, make sure you email me by Thursday so I could set up some time to help you. But hopefully we're all good. Hopefully we're able to learn with these videos. Hopefully this format of practicing and then seeing me do it, hopefully it's working. So that's it for today. I'm going to close in prayer, and then that'll be it. Lord, I thank you for this time. I thank you for this Legacy Ministry College. I thank you for the students. I pray, Lord, that you would use this time, that this wouldn't be wasted time, that this wouldn't be pointless for anybody. Lord, I pray that this time would honor you. I pray right now, Lord, you know everything that's coming. You know everything that's going on. You know every moment in time that could come up where we would use any of these skills. So, Father, I pray for the things that I've said, the skills that are useful to these students. Just seal them in their mind, Lord God. Give them a supernatural understanding. Give them wisdom, Lord, for those that struggle with math. I just pray for peace. I pray for peace that goes beyond all understanding, Lord. For some students, maybe it's bringing up some hard times in a algebra class. Father, I pray that this would be different. I pray that the numbers that you invented, Lord God, these math principles that originated in your mind, God, that these would not intimidate the students, Lord, that they would have peace, that they would have an understanding. And Lord, I pray even for some who hated math back in the day, I pray that in this class they would even enjoy it, Lord. I pray that you would, Lord, just let math be a new thing for some of these students who have hated it, Lord. And we pray that our efforts here would be honoring to you, Lord. In Jesus' name, amen. All right. I will see you all next week.